And it is time, so we're going to begin. Welcome to the SIDROPS session here at IETF 123. Next slide. Oh, you gave me the clicker. This is the IETF note well. Please make sure you understand your rights, privileges, and responsibilities. And that includes disclosing IPR and treating each other well. Next slide. Yes. Reminder of the code of conduct. Please actively participate respectfully. Remind that everybody needs to get into Medico, even if you're in the room, because this is how we will manage the queue so that both people in the room and people remotely can get a place in line. So before we get into the presentations that have been scheduled, we've been having this debate on the mail list about PDU ordering. And about half of the people are concerned that the ordering needs to be fully specified. And other people have voiced the view that we only need to specify enough ordering to avoid race conditions, and everything should be left beyond that. Would like to get a feel for the people who, I'd like to settle this if possible, right? Because this is the point of contention blocking forward progress on this doc, and it is the only issue of contention that remains at this point, as best I can tell. So I'm going to do a straw poll that is full ordering absolutely needed is the question. Any question bashing before I start the poll? Okay. Yeah. Rudiger.
What is the client supposed to do if it detects that the ordering is not perfectly aligned to the specification? And is it supposed to actually check that?
That has been part of the argument that has been shared on the list, which is it makes the protocol more fragile if you start rejecting because your view of the ordering is different than the sender's, than the cache sending. The client has one view of ordering and the cache has a different. Okay? Do you understand?
Yes.
Okay. So I'm good. I thought you were bashing the question.
Let me bash the question Jeff has. Your question is provides benefits. That's different than requires total ordering.
Yes, I was hoping to. Okay, let's do exactly that question then.
Is a question.
Small comments, Job Snyders. I think there is consensus that race conditions exist. And this to me is
yes.
news. Like, okay, that means we are looking at the same problem space. And it was pointed out by a number of developers that a total ordering is easier to implement and easier in the specification than a partial ordering. So why some proponents advocate for total ordering is that there is less ambiguity. The question, what clients should do, in my opinion, we haven't had good working group-wide debate on what the pros and cons are and what it means if a server is non-compliant to total ordering, because we're somewhat stuck. So I appreciate that we're trying to navigate through what the working group thinks, and thank you for that.
Okay. You're correct. So if we would answer this question, yes, no, or no opinion?
There might be some details on technical details that need still to be defined or discussed. But point here is whether or not we want the ordering. Then everything else comes afterwards. We will work depending on the direction the group chooses.
All right, the numbers seem to be stabilizing here. So roughly half of the people think that the ordering gives benefit. 2 think it does not, and 13 have no opinion, which means that I think we have set a direction to put the ordering into the document. Okay? Yes, you.
Yeah, this was a useful exercise. As was mentioned, there are certain technicalities where I would love more debate. That we present arguments back and forth and don't wave away like, well, I just don't feel like a particular direction. An issue with the text as it is in the current draft is I think that text is not the type of quality we're aspiring to when producing documents. Regardless of whether you want ordering or not, the text as is difficult to interpret. So I would love that whatever the outcome of this exercise is, that the text is updated to align with IETF traditions.
That's exactly the point. I mean, and not to say, okay, we'll keep the section with the ordering as it is to, as a group, to work on until it's okay for everybody.
Yep.
As for today, we will work on it. That's the decision today from the group. Then we will continue.
Okay, so now we're going to turn to the presentations that we have queued up. There was a fair amount of discussion on the list about what order we should do this in. This puts the adopted work before any proposed new work, and it puts the things that were discussed most on the list before things that were discussed barely at all. Okay, so this is the order that we're going to go through the presentations. And Sriram, you're first.
Good morning, Sriram from NIST. So there have been some discussions on the SIDROPS list about some issues related to ASPA verification. I'm going to summarize those and mention some conclusions that we could be reaching based on that discussion. I thank Maria and Gia for some of the discussions in person after coming here in the last 2 days. So first, before we get into those issues, I just want to mention a little update about the test cases. A slightly updated list of test cases for ASPA verification are available at this GitHub site. There was a typo, minor typo that's been fixed, and this GitHub website is up to date. Thanks to Jacob for pointing that out. And at this point, several implementations have verified correctly against these test cases, Cisco, APNIC, POC, NIST BGPSRX, RTRlib. I think I'm still waiting for a final confirmation from them, but they are also working with it. Now, regarding the issues that we are lately discussing about ASPA verification, I raised a question on the SIDROPS list about how best to deal with the network operator error in the creation of ASPA. There are some links to those discussions here on this slide. So the question is, on the left side, the customer's customer makes an error with regard to the ASPA. They omitted including their provider, ASC in this case, and it's the customer's customer who made this omission error. And at ASM, which is the verifying AS, there is no issue because the update would be evaluated as invalid because of that omission. But if it is a direct customer, as shown on the right side, the ASPA algorithm as it currently works does not label this route as invalid. Because ASC is a direct customer, and they have exchanged BGP roles as well, possibly based on RFC 9234, and the relationship is mutually verified, and based on that, they have configured each other. And also, ASC could be a long-standing customer with an established BGP session. Given all that, if ASC on one day transitions to doing ASPA, and they create their ASPA and make an error, should the provider be harsh and cut them off because of that error? Or should they try to fix the error as soon as possible in coordination with the customer and let the BGP session continue and receive and propagate the updates as they would be valid according to the current algorithm in spite of this error, because the algorithm is driven by the local configuration of the relationship, which is customer provider. And based on that, the ASPA verification algorithm determines that this update is valid. It doesn't look at the ASPA of the immediate neighbor. And if we are concerned about the error and so subsequent ASS, after this update propagates from ASM to further out, ASS that are doing ASPA would find this update to be invalid. However, in partial deployment or if there is no alternate path, if there is an alternate path or in partial deployment, many ASS would continue to have reachability to ASC or the prefixes at ASC. So the question is, do the operators want to drop the updates, or do they want to be tolerant and then fix the ASPA error as soon as possible as an operational procedure or as an automated procedure we will describe? So before we go to that, there has been some discussion about whether egress verification is necessary. So regarding that, Maria and myself have discussed it quite a bit on the list as well as here, and Gia has also been involved in some of these discussions. What we find is that the ASPA draft specifies using ingress verification and OTC. If there is no error of omission, or if that is prevented quickly, then the ingress verification plus OTC inherently works to prevent sending invalid routes at the egress. So there is no question of like sending out invalid routes if the ASPA error of omission doesn't happen in the first place, or if there is a mechanism to quickly correct it, and in that case, everything would be fine. So we are proposing multiple proactive methods for detecting mismatch between the BGP session configuration and the ASPA. That's the key issue here. And those methods should be available for the network operators. The draft describes some of them, and it will describe some additional ones that we will talk about in a moment. This mechanism of proactively preventing the error also makes sure that the OTC attributes errors are prevented as well. So there are like 3 slides where we talk about the proactive measures for preventing the mismatch, for detecting and preventing the mismatch. So the first one is the AS periodically monitors relevant ASPAs in the global RPKI repositories and checks that all their provider ASs are included in their own ASPA towards the provider, looking towards the provider, then looking towards the customer, make sure that their AS number is included in the SPAs, the set of provider ASs of their customer ASs. And the third one, they have BGP role configured, and they should make sure that the configured roles are according to RFC 9234. The BGP roles and the ASPAs should be consistent. Additionally, we can have implementations can optionally make available a tool to detect mismatch between BGP session configuration and ASPA. For this, 2 simple things can be done. One, looking towards the customer interface, it can form a test path that consists of local AS and customer AS. So just 2 ASs in the path. And this is a synthetic path. It's not coming from an update. You are saying that what if I get an update from the customer AS and I'm the local AS? Would I consider it valid according to the upstream ASPA algorithm? And if that check fails, then that is an alert about a mismatch. Similarly, looking towards the provider interface, I create this test path, provider AS, local AS, and and again apply the upstream path verification on this path. And if it's invalid, that is again an alert about the mismatch. So those are 2 types of preventive measures. And then finally, we would encourage, the draft would say that we encourage the development and use of features in ASPA creation systems, such as the RIR hosted systems, delegated CAs that would preview and warn the user that the ASPA they are about to create would render some existing routes invalid. Also encourage tools that provide continuous monitoring of ASPA invalid routes from global BGP trace data. Only the little caveat is that for the majority of ASS it works, but for a few, some ASS and their historical or backup neighbor relations may be hidden from the BGP trace data. I think that's the last one, yeah. Any questions, particularly if there are operators in the room or others have an opinion about whether based on an ASPA error from your customer, you have configured them as a customer. Let's say they have a well-established BGP session. Do you want to ASPA verification to detect the update as invalid, not only the customer's prefixes, their entire customer cone, or do you want to just, are you happy with doing proactively checking whether the ASPA has been, is in error, but it can be fixed quickly? Go ahead.
Yeah, Tim Ruijsens, Ripens to see. Before I start, you first want to talk about the operational side, because I wanted to talk about the preview and interface side. So I can wait as well.
Yeah.
Okay, then maybe let others comment on the operational side first. And do I need to rejoin or can I just walk to the end?
Oh, good. Rüdiger Volk. I'm unhappy to see the draft grow in size and essentially complexity. The main point that I'm seeing from the discussion is, and I would like to have a little bit different point of view used there. For a long time, I found very clear explanation for the owners of ASs what they should consider correct ASPAs to register and what the consequences of what error in that registration would be. Kind of, you are talking, well, okay, at least one AS away, but kind of, I would like to see a very clear explanation for the end AS to make sure that it actually knows what to do correctly. Kind of, yes, errors will be made and people in the context will have to deal with it. And yes, we can think about what to do there, but the first thing is to explain to the people exactly what to do and what to expect if they fail. So let me complete here, and I'm kind of going into a tradition from a senator of the classic Roman Republic, who always ended his speeches with "Ceterum censeo Carthaginem esse delendam." Ceterum censeo. I do not think that we would use the word of verification here. And people who want to well, okay, actually look into this can go to RFC 2828, which explains the official terminology for security in IETF. And it explains that certainly this is not verification. It is validation.
Rüdiger, I wanted to get a clarity. If you are saying that these errors in the creation of ASPA, that is something not to be dealt in the ASPA verification or validation algorithm, is that what you are saying? It should be.
Well, kind of. We are validating an AS path attribute where we do not know whether it is actually authentic against policy. And you cannot call this verification. Verifying the AS path would mean that you verify that it is actually authentic. And that's the job of BGPsec. And unfortunately, I did not make that distinction at the time when we did do BGPsec.
Okay.
And we kind of replace any occurrence of verification or verify in the draft by validation or validity. Nice enough. The results of the algorithm as coded in the draft are valid, invalid, or unknown.
You're talking about
not true, failed, or unknown.
Okay, let me follow that up with you later. Thank you.
Yeah. So again, Tim Bruisels, RIPE NCC. Thank you for doing this work and exploring what can go wrong and what might need to be done in such cases. In the interest of time, I'd like to follow up maybe offline with you to understand some things better. But what I did want to say is we have plans to work on an ASPA implementation on well, we have it in the API of a test environment, and we want to make a user interface as well. We've been thinking about how can we help people avoid making mistakes. So let's have that talk. Just shooting from the hip, I think it might be a useful suggestion indeed to enrich such a UI with tooling that allows you to test what would happen if before you do it. It would also help if we can look at existing BGP information to help guide people. But one of the challenges there is that we may not have a complete view. So that's our challenge. So whatever we do, we have to be careful that we don't presume to tell our users that we know exactly what you need to do, because you probably don't, I think, but let's have a talk and explore what we can actually discover.
Okay, I would appreciate that. I want to emphasize that the ASPA is ASPA follows the configuration. So creation of the ASPA by an AS for a peering session follows the configuration of the session. So if the configuration is correct, especially we are strongly recommending that you use RFC 9234 BGP role, and if that is used in conjunction with ASPA, then the probability of misconfiguration is very low, and therefore the probability of because the ASPA is driven by that, the probability of creating a wrong ASPA would also be very low. I just wanted to mention that. Yeah, next question.
Hello, Nangang from Huawei Technology. First, I just want to confirm that will the egress verification be added into the new version of this draft? Will we have a section to describe the egress ASPA verification in the ASPA verification draft? That's my first question. Just want to confirm that.
So is your question, would we incorporate egress verification into the ASPA verification draft?
Yes, the egress verification included in the draft, right?
Right. So we are saying that the combination of ingress verification and OTC, it inherently works to prevent sending any invalid routes on the egress at the egress. So based on the discussions that Maria and I had over the last 2 days, we are confident that this statement is correct. That so egress verification plus OTC obviates, it makes it unnecessary to have egress verification in addition.
Okay.
So unless we are convinced that the egress verification is necessary, especially with these approaches of preventing. Already the possibility of the ASPA error is low. In addition to that, if we have these proactive methods to prevent that and correct that, then I think we can just stay with ingress verification plus OTC.
Okay, I understand. I also follow the discussions in the main list. And my point is that, as I was suggested into the draft, I think egress verification is useful. And there is one advantage of egress verification. That is, ASPA-based ASPA verification is a one-point mechanism. We can upgrade one device and enable the function in this device. We do not need the cooperation between multiple devices, I mean routers maybe. So that's the advantage of the egress verification. That's what I want to say. And maybe can we consider a scenario that we only enable ASPA-based verification, because as you described in the mailing list, there are two challenging use cases that egress ASPA cannot solve them efficiently. So, but for example, in use case 2, you describe mutual transit scenarios. ASPA cannot efficiently, and is this kind of complexity relationship is only a small proportion in real networks. So maybe in most of cases, we can use ASPA egress verification. That's my second point. Thank you.
Yeah, so just we are not totally dismissing the egress verification. We are just saying that if you make it on inline yeah, if you make it inline, what happens is that you are doing the verification at the egress, then you're doing OTC, then possibly you are doing the egress verification redundantly. So we just want to make sure that if there is a BGP session reset, for example, there would be 1 million updates that would be received on that session all of a sudden, and then doing both ingress verification and egress verification on all of those BGP updates, 1 million of them, especially when egress verification is redundant, should we really be going there? That's a question. And we are not dismissing egress verification altogether. When egress verification, we are keeping it not inline, but offline as a tool. The AS can run these second and third bullets, which are basically egress verification towards a customer, towards a provider. By doing that, they can immediately detect that there has been an error in the ASPA. And this is one of the tools we are providing where egress verification is considered, and it can be included in the draft. We propose to do that. And but it is not inline. It is not in line with the ASPA verification. It is something that you do it once and detect whether you made an error and fix it quickly. Thank you.
Hi, sir. I'm Sheng Lin Jiang from Zhongguan Library. I'd like to know how to ensure that the relationship in register ASPA object is accurate. The ASPA the register ASPA object is accurate. Thank you.
Sorry, I couldn't understand.
That the provider to customer the relationship is accurate.
Yeah,
how to ensure?
Yeah, so let's continue this discussion after one-on-one.
Oh, okay.
I just want to mention that that is what we are focusing on here, how to detect that there has been an error in the ASPA by multiple ways of proactively detecting, multiple proactive detecting mechanisms, right? But we can talk one-on-one. Anything else? Maria. Oh.
Just a slow comment, just a little comment. I wanted to clarify that the configuration of ASPA should actually be in line with the OTC, but not in the way that I first configure the OTC and the sessions and then I sign the ASPA, because this would mean I am sending invalid routes in between. I have to set this in my single source of truth. Then I sign a new ASPA from that, and then I can set up a session. Just the same as with ROA. When I'm getting a new IP address prefix, I wanna first sign the ROA and then I can advertise it, not the other way around. Just a clarification. Thank you.
Thank you, Maria.
Thank you, Sriram.
As soon as he clicks that button.
Yeah, hi everyone. Tim Rijels, welcome to see you again. I wanted to give a quick heads up on the publication server best current practice document that me and some other folks here have been working on. That actually went to last call and then came back. We'd like to progress it. But before we do, I want to make sure that when we do, we don't have to, move it back again. Well, maybe that's my whole presentation, actually. So the history. Old versions were there. This is what I just said. It went to last call. There were some comments. We addressed some of the issue, in particular terminology and clarifications. Like I say here, grammar, readability. Terminology, we were talking about RDP repositories, where we maybe should have talked about servers to make the distinction more clear, whether you're talking to the thing that a publisher talks to, or the repository usually is referring to the data, let's say, that is being retrieved. Job Snijders in the room here as well was added as a co-author. He contributed earlier as well, actually. What is still open is some suggestions by Chris Morrow in particular. I'll get back to those in a moment, but the struggle, I guess that applies to any desk current practice document beside, when is it actually done, because current changes every day, is that you likely want to balance the level of information to give actionable advice to people, general advice. You can do more specific suggestions, but you don't want so many of that it becomes confusing, or that people interpret this as this is the only way to do this, where there may be different choices. So that is, that's just what it is, I guess. That's the struggle of everybody writing these documents. So particular suggestions made by Chris were mainly around single point of failures. And they do make sense. But the question that I have is, are they really general enough? Because it really depends on your local setup, whether all of these things apply. Should we include text on this? And as I said earlier to Chris, please provide some text if you have some. But if your name is not Chris Morrow and you have an opinion on this, please do make suggestions. Next steps. Well, if you operate a publication server, please read and comment before we go to last call again. But if you're a researcher, and I know there's some here that like to break these things, also please read it and comment, because, well, I'd rather fix it before last call. So we are looking at possibly a small update for a 04 version, dependent on what we hear back from you. And then we'd like to go to last call, take 2. And I don't have a question slide, but it's implied. But we can also take it to the list, of course. But if anybody has comments right now, then I'm happy to have that talk.
Michael in the queue.
Hi, Mike Holloman, VeriSign. Thanks for the document, Tim. I like all the work you're doing on this. And I think that for current operators as well as future operators, it's a very important thing for us to have. Sorry for the late suggestion on this, but one thing I just thought of is I did some looking last week, and there's about 20 publication points today that have DNSSEC entries for their distinct host names. Maybe it's worth just adding a blurb in that section on distinct host names to have DNSSEC as a recommendation. Okay.
Thank you, Tim. Thank you.
Hello, everyone. Thank you for giving me this opportunity to give a presentation about more file formatting arrange authorization. Yeah, this is about a new digital sign object or PKI. It is used for the validation of the address mapping announcement in multi-domain IPv6 only underlying network. This draft was adopted by SIDROPS working group October last year. The current version is 02. It has been 1 year since the last presentation, so I'll give a brief background. As mentioned, that this is for IPv6 only network. For IPv4 service delivery IPv6 only network, IPv6 mapping prefix will be used at P devices to identify the location IPv4 of each IPv4 network. So mapping prefix is used as a considered mapping origin of the given IPv4 address block. So this is about the problem statement. To validate IPv4 service data in IPv6 only network, relies on the authenticity of the mapping origin of the IPv4 address block. If attack maps IPv4 address block using a fake IPv6 mapping prefix, IPv4 service data will be routed through the attack controlled route and reach to a wrong egress PE, resulting in a situation of IPv4 prefix hijacking. So this is serious. So to deal with this problem, this approach leverages RPKI architecture to verify the authenticity of the mapping origin of the IPv4 address. And here, more is a cryptographically signed object between IPv4 address block and its right IPv6 mapping prefix that is known to be declared in the BGP announcement. So with this object, a legitimate holder of IPv4 address block, for example, ISP can authorize IPv6 mapping prefix to map the IPv4 address block. This is a Ethernet more object. It has been approved and revised by Russ and Jobs Slender. Thanks. So as a RPK object, before reliable party user more to validate mapping announcements, the reliable party must perform all the validation checks by the EFC's 6488, as well as additional more specific validation step. So there's a little update to this draft. We just moved the FORMAP6 based BGP extensions from the normative informative to informative reference. So the major update may be implementation. Right now, we are implementing the more system based on RPKI. The implementation include two parts. The module of CE part and the module of RP side. So at the CE side, for example, operator may confirm that a CE certificate has been received from upstream CE. So it will use this CE certificate to issue E certificate containing an IPv6 address prefix. Furthermore, this E certificate will be used to issue a digital object containing IPv6 address prefix and set of IPv4 address prefix. Then the E certificate and the digital object will be encapsulated into a more file and uploaded to the repository. So for the process on the API side, it will build a certificates chain from the E certificate embedding more to T certificate. Then we will verify the legality and validity of all the certificates on the certificate chain. And we'll also verify whether IPv6 mapping prefix and IPv4 address prefix in more are included in each certificate in the certificate chain. So at now, we opt get the IPv6 mapping prefix and IPv4 address block binding relationships. This is about in the process. Currently, we have finished implementation of the CE side. So the more certificate can be successfully issued on the CE side right now. Next step, we'll continue to the implementation. We'll implement the more certificate passing and the verification on the RP side. And so we'll realize end-to-end verification of the system function. And we hope to give a full demonstration of next IETF meeting. And we also plan to design protocol between RP and the RP router and the router. That's on my presentation. Thank you.
Any questions? Job? Yep.
Job Snyders. I cannot comment on the validity of the technology that you present because I'm not an expert in V4, V6 mapping. But I noticed there's a draft in V6 ops, there's a draft in IDR, and now you have a draft in SIDR ops. And from a procedural perspective, I think this is something for the chairs to consider. Is it really necessary for this draft to produce, to go through SIDR ops? Because in my mind, yes, you make use of RPKI, so SIDR ops should review it. And we provided some review, happy to do it again. But other than that, I'm not sure it is a SIDR ops specific topic. But I also don't know what the logical working group would be, since you're already spreading the drafts out through multiple working groups. So yeah, this might be something for the chairs to consider. Like, is this really the best place? If yes, so be it. Or maybe there's a better working group.
Well, we already did the call for adoption last year, and at that time, there was people interested in the RPKI objects being defined here.
And a final question, on slide 10, you have DR decoding. How did you make that? It looks really pretty. This one, yeah. Oh, back, yeah.
Yeah.
What is the tool?
With that tool. So I hope my cross Mati can answer the question.
What
Sorry?
tool did you use?
How
Yeah.
did you make this?
He helped me to implement this. And
Okay,
he can
very
answer the
cool.
question.
Yeah.
Yeah, Mati, can you answer the question?
Yeah, this is Dima from ZDS. I think I can take your question. And my team, as you know, are maintaining the open source RPSTR. So we has tested this extension to the RPK by do some extended function with the RPSTR tool. Yeah.
Mm-hmm. Thank you.
Okay, thanks.
Thank you.
Thank you.
Let's move forward.
Oh, hello, I'm Jia from Zhongguancun Laboratory. Today I'm going to introduce our draft on ASPA-based AS-pass verification for BGP export, where I found it's necessary to perform egress verification. And last meeting, I have introduced this draft with the initial verification procedure, and the primary feedback centers on its technical necessities. So in this revision, we have directly addressed those foundational questions. And special thanks to Maria for providing critical beneficial cases. And now we are co-developing a new version of this draft. And first, let's revisit the verification procedure of the egress verification. As for the eBGP egress router R2, it will first prepend the local OS to the received AS path, and then it will use the relationship between the local AS and the next hop AS to determine the direction of the verification, which means the verification is from the perspective of the next hop AS, which is ASY in this figure. And the R2 knows the relation with the ASY, so there is no need for further transmission. And as for the necessity for ASPA egress, it enhances ASPA deployment by solving three critical gaps. It blocks local AS misconfigurations as a source and completes ASPA security model by preventing local root leaks, and it accelerates registration error detection. Firstly, performing egress verification could prevent local AS misconfigurations. For example, in the case of AS federation, it blocks accidentally injecting internal AS to the received AS path. And during AS path manipulation, such as prepending or aggregation, it will catch the errors before propagation. So it could prevent the local AS from advertising routes with invalid AS paths, catch the errors, just like RV egress does for invalid origins. And secondly, it completes ASPA-based verification method by performing egress verification could help the operators to prevent local root leak with ASPA. And of course, here is some existing solutions for preventing local root leaks, such as only to customer and down only. But compared to those methods, improving ASPA can still bring several benefits. The first is ASPA provide out-of-band route validation, decoupling from BGP configurations. Of course, OTC and DO are really effective mechanisms when used properly, but it requires per session BGP configuration, while ASPA is out-of-band, which means that it eliminates the BGP dependency and mitigates the risks of misconfigurations. And also, ASPA offers distinct security and operational advantages. Clearly, OTC has no built-in anti-tampering mechanisms and missing integrity verification. And as for the operational complexity, OTC requires per session BGP role configuration, and it also needs the neighbors to have their routers upgrade to communicate their BGP role. While just as Nan said, ASPA is one point, which means ASPA only needs their neighbors to have registered their ASPA record. That's enough. That's enough for the local AS to do the verification itself. Okay, and thirdly, performing egress verification could quickly detect ASPA registration errors from the local and customer, which will prevent the route being invalid and filtered out remotely while the local AS are unaware of this situation. Just as the table shows, if ASA has ASPA but omit at least one of its provider, in the upstream scenario with the current ingress algorithm, the local ASSA and the provider ASSB will show valid, while the ASC, which is 2 hops away, will find it invalid and filter it out, while leaving the ASA unaware of this situation and don't know why the connectivity fails. But with egress verification, ASA's provider ASB will find it and could notify ASA. And the same logic applies to the downstream scenario that with egress verification, the registration error could be found locally faster than the ingress verification. And for this issue, Maria has proposed a new solution on the mailing list, and which will achieve quicker, faster registration error identification, and we're still discussing the details of the scheme. Also, yeah, and Maria's solution also require egress verification. So performing egress verification could detect such registration errors immediately and point to its actual source clearly and noticeably. Okay, and here are also 2 questions from the last meeting. The first is egress verification is an issue of implementation, and does it require a separate specification? And our answer is yes. Vendors need standardized specification to define how to deploy egress verification, as its procedure is a little bit different. And the second question is, as the local AS knows the relationship with the next hop AS, is the local config with the config file is enough to address such issues? Actually, R2 has limited information as it only knows the relation with the next hop AS ASY. It don't know where the route is come from. So it still needs the support from the ASPA record. Okay, that's all we want to update, and we believe performing ASPA-based ASPA verification as an egress is very necessary. And just as Sri Ram said, maybe some part of this egress, he think maybe some part of this egress draft will be included in the main draft of ASPA. So I strongly thinking for guidance and insights from the community on how to improve this egress draft. Okay, and thank you, and many thanks to those who give us valuable suggestions and comments. Thank you.
Sri Ram from NIST. Can you roll back to slide 7?
This page?
Right. So regarding the security considerations comments about OTC, what you are saying is generally true, but what we are concerned about in the context of ASPA verification is just the simple OTC propagation from the ingress to the egress. So that is happening within the AS that you are at. It's your own AS. And there we don't have a security concern. It's just whatever OTC it came in with, and if it didn't come in with an OTC, we set the OTC on the ingress router and it propagates to the egress router. So it's within the AS and there are no security concerns there. You want to clarify that?
Yeah.
And I appreciate your efforts very much. And we have talked quite a bit on Sunday, and then we'll continue to talk. So I would like to, for us to understand fully, like what are the implications of egress verification, where it can benefit, where it might just be redundant. So we'll continue that discussion, and I'll clarify everything between us and together with Maria, who is also interested in this. So you are right that we are not ignoring, will not be ignoring some mention of egress verification in the ASPA verification draft. We are just hesitant about making it in line because maybe it doesn't make sense to process, like I said, 1 million routes at the ingress. When there's a BGP restart or something like that, 1 million routes, you do the ASPA verification on ingress, and again repeat that at the egress when that the latter part is redundant. So we need to understand that and close the loop on that. If the operators are willing to accept that these preventing mechanisms that we are proposing, first of all, as I already said, the probability is low that there will be ASPA error. But still we can get feedback from the operators. We can talk to them individually here and see that they are satisfied that, if we can take care of the ASPA omission error through these preventive procedures that we are mentioning, you have to, like Maria said, you have to synchronize various operations. You first have to receive all the RPKI data, and you have to check the sanity of it. And in that process, it's a very simple thing to look towards your customer and look towards your provider and perform a simple check with those two paths that I mentioned, just yourself and your customer, or yourself and your provider. Just consider that path and do an upstream verification. By doing that, you can readily check the sanity of the ASPA, whether it is correct or incorrect. And once you have that, you're fixing it right there. Although it's not inline, it is offline. But there is the implementer can provide a tool to quickly do that and keep, as soon as there are any RPKI changes, this can automatically run and alert the AS operator. And that way they can make sure that the ASPA errors, if at all they happen, it's very rare, but if at all they happen, they are quickly caught. So those are some of my comments, and we can continue outside.
Okay, thank you. And what I want to clarify is that we are not going to replace OTC, but maybe ASPA egress could provide auto-bind verification, and when OTC may have some misconfigurations, the ASPA record can cross-check with OTC, and also the egress verification will ensure that the AS are not announced a route with invalid path, which will be verified as invalid remotely. This is what we want to do, and yeah, that's
continue.
Okay. Thank you.
Thank you.
Thank you.
Hello, Nangang from Huawei. Okay, one comment to the last draft, very quick. I don't think it's redundant to use both ASPA egress verification and OTC because there are two main paths of OTC. We can do BGP session negotiation at the start of the session, and second, we can add the BGP OTC attribute in the BGP update routes. So we can use them separately. And when we do egress verification, we can just configure the BGP role on the BGP sessions. And in this case, we do not need to use the OTC attribute.
Quickly, yeah, we can, Maria, yourself, Gia, and myself can meet. We can clarify these questions. It will take a while to do that here, but we'll certainly discuss and further clarify before we leave Madrid. Okay?
Okay.
Thank you.
Thank you.
Hello, this is Yang Feiguo from Zhongguan Laboratory. Today, my topic is about BGP AS path verification based on route path authorizations, that is RPA. This topic is, involves two drafts, that is item 6 and item 7 on the agenda. Okay. So first, let's review the basic BGP the basic BGP route propagation pattern. This is design design principles of RPA. For untransit AS, it receives the routes from previous AS and accepts them. Then it may update routes to next AS according to local routing policy. In this pattern, only 3 AS are involved: the previous AS and the local AS and the next AS. So the RPA, the goals of RPA is to detect route propagation that violates local routing paths, and it can prevent route leaks. The idea of RPA is coming from IR auto number, but as stated in FC 7682, issues with data quality have limited the practical use of the auto number objects policy attributes. So we design RPA, and the content of RPA is as this structure. It contains a version default as 0 and an SID field. It means the local AS number, and it has a list of route path blocks that describes the routing path. Each route path block contains one previous AS set, next AS set, origins, and the prefix field. The last two fields are optional fields. Next, I will introduce you how to register RPAs. This scenario is the permitted routing path from ASA to SD has two paths, A, B, C, D, and A, E, C, D. So each AS has registered their RPAs like this list. We will take the bottom format to represent RPA. In this case, RPA A and RPA D are special case because the ASA is the originator of this route and SD is the destination of this route. In this scenario, ASS has registered RA or SPL, so it can fill in the origins AS. RPAC has taken this route to limit the route from ASS must be routed following this path, that is S, A, B, C, D. So it adds a route path to RPAC. The next scenario is about SC has registered another route path to its RPA object. It has specified the prefix PA must be routed following this path AECD. The next part is about verification. We have divided the verification into two paths, two steps. Step 1 is the POS verification. Step 2 is the whole BPS path verification. In POS verification, take ASC as an example. If ASC has registered RPC, and then it will check the prefix. If RPC contains one route path block and the received prefix P belongs to its prefix, then and the ASE and ASD conforms to the route path, it is valid. And so, if RPAC contains an route path that ASX belongs to the regions, and the ASE and ASD belongs to the match to the routing path, it should perform RV and SPL. Otherwise, if RPAC doesn't specify the prefix or origins, but it has one route path block that matches the AS path, it can also be valid. In other case, the verification result is invalid. But if RPAC doesn't be issued, the result is unknown. In the BGP path verification step, for SD, it should first verify each RPA and get the results. If each RPA verification result is valid, the BPS path verification result is valid. Otherwise, any RPA verification result is valid and others results are unknown, it is weakly valid. That is our introduced in RPA verification. Any RPA, otherwise, else, any RPA verification result is invalid and the verification result is invalid and others are unknown. We have analyzed the total number of RPAs. As one S only needs to register one RPA object, so we have referred to the auto number objects. It has about 80,000 RPA objects in total. We have collected some comments from the mail list. As for the scalability, ProS has only one RPA object. The total number of RPA object is similar to the active as number in the internet as we have analyzed in last slide. As for security and partial deployment, deploying brings immediate benefits. We think that because once AS is deployed, it can prevent malicious actions from the upstream AS and prevent route leaks caused by misconfiguration as downstream AS. As for privacy, it is recommended that AS that are vulnerable to route hijacking or route leaks register first because we have two steps verification, so it can only perform the POS verification. And how does RPA object get bootstrapped? For simplicity, we think it can start from the IRR auto number. And compared with ASPA and ASTRA, what are the advantages? By taking prefix into consideration, RPA provides more fine-grained anti-hijacking protection and traffic engineering capabilities. That's all. Thank you.
Maria again here. I'd like to ask you, how much are you expecting the operators to actually fill the objects and keep them accurate? We have already been thinking about problems with discrepancies between ASPA and the BGP roles set in their own settings. How do you expect that this could be explainable to the operators in those village ISPs, to put it weirdly, who would need to understand the whole problematics, the whole concepts to actually deploy it well? Because this is in the end who should deploy it. This is the target group. And I am very afraid that even with ASPA, we are having problems with explaining things. Let's aside this. Thank you.
Thank you. I will answer at the mail list.
SIDR NIST. So this, the question on the slide here, how does RPA object get bootstrapped? That question basically is, it's basically we're asking, how do you determine the set of prefixes that you insert into the RPA? And you are saying that that you are going to use OTNUM, etc., import-export policies. But you know, you really need to carefully consider whether the prefix route that's been received on that interface, whether the route has a route leak in it, whether the path has been manipulated. And right now, the best mechanism we have to detect those are the OTC and the ASPA. So if you are saying that in order to have a clean prefix list to put into RPA, you first have to do ASPA and OTC, etc., and then you come up with the prefix list. So then you are defeating the whole purpose of proposing an alternative or even an enhancement to ASPA, because you are highly reliant. You would be, I mean, well, based on what I am thinking, you don't have any other good mechanism to filter out the bad routes, the bad prefixes. If you just take the BGP input into the interface coming in, and if you just populate the RPA with all those prefixes, okay, you have, I mean, first of all, you have the problem of route leaks in there. You have the problem of manipulated AS paths. You need some mechanism to first detect and filter them. And after that, BGP is a dynamic process. You are receiving more updates. You are getting withdrawals in response to all of those. If you keep modifying the prefix list over and over again and update the RPA with each BGP update that comes in, each withdrawal that comes in, if you have to keep modifying the RPA, it is a nightmare. I mean, it's simply not conceivable that one can do it.
First, I think we have to answer your question as a mail list. As there, the origins and prefix are optional fields, so that they can be omitted. This is this you said it more like ASPA, but we think it's different from ASPA because it provides this specified prefix. The specified prefix they are not necessary in here.
Yeah, so there the question comes in, it may be abused. When a AS wants to leak a route, it can abuse the RPA. It can maliciously put in its own AS as the provider while it is a customer. And then you will again have an issue with like the possibility of malicious attacks on this scheme.
As for the abusing problem, we think that the prefix and the origins are protect the most high priority targets. Not all of them to reject the prefix and origins.
You mean ROA protects?
No, the ROA. I mean, not all of the AS to reject the RPA should fill the origins and the prefix. They can be left as none, as MPT.
Yeah, even if you leave empty, even then, well, the attack that I just described to you is entirely possible. The customer AS can insert themselves as a provider in this arrangement and cause and get away with a route leak. So you need to think about that.
I think there is no customer and provider here.
No,
that's the routing path.
Yeah, you don't. Yeah, right, that's right. You don't explicitly say customer provider. You just say the AS before me and the AS after me,
yes,
right?
Yes.
So even then, the same attack can happen. You're still allowing the attack that I described. The AS in the middle wants to leak the route from the AS on the left to the AS on the right, and it can create this object, and your validation won't be able to catch that intentional route leak. Think about it.
Okay, I think we can discuss that offline.
Okay.
We need
And-
to take this to the list.
Okay, one more question about the comparison with ASPA, but we'll take it offline.
Thank you.
Thank you.
Rudiger?
Well, okay. Let me first do the simple comment. When you say you are doing ASPath verification, you certainly are not making sure that that the ASPath attribute in an BGP update that you get is true. You may call it validation, not verification. First, very simple. Well, the kind of how much data do you think a medium tier transit provider will have in their RPA? Say 100 transit customers and medium tier 200 peers. And yeah, well, okay, that's as a scalability point.
So I have set the road path block, and so that one AS would register one RPA to shrink the number of RPA. That is the first, and the next. The second is that we set 3S as set. The previous S is as set, next S is as set, urgency is as set to shrink the number of road paths block.
So how many kilobytes of content would you assume for the example?
Maybe one.
1 kilobyte.
But no.
Pardon?
Maybe one, because they are all in the same route path block.
Yeah, well, okay, kind of my question is, well, okay, if I have 300 neighbor ASs, that RPA block would at least need something like 300 by times 4 bytes for just listing the neighbors.
But they may in the same as that.
Yeah. Yeah, kind of. I used to try to do RPSL ordnum for a serious network, and well, okay, I made use of it, but kind of it gets out of hand.
Mm-hmm.
Yeah.
Okay.
And kind of in RPSL, our assumption was essentially to do one ordnum object for your AS and do that as a specification for your AS external BGP configuration, and actually not look into the rest of the IRR for all what's there in the ordnum objects. And here you are obviously supposing that you are looking back and forth and side and up and down. And it's just not manageable.
Yes.
Sorry to interrupt. Maybe we are really out of time. There are several concerns, so we can take it to the list. Jeff, if it is quick, please.
I will try to keep this terse. So Rudiger made some of my points. What you are effectively doing here for validating the AS path is very similar to what SOBGP was attempting to accomplish. Yes. So I would suggest taking a look at the prior SIDR mailing list discussion about that proposal for the path validation component.
Okay.
So that will help you with that piece. I pasted to the chat the SOBGP certificate, which is not exactly this, but very similar. Rudiger's point more tersely is that you are effectively doing an RPSL autonome object with the import and export clauses, trying to limit things. You will find public presentations on NANOG covering use of high-scale IRR usage by both Deutsche Telekom and also Level 3. And as the vendor who implemented a lot of those policies, you're going to find that even for semi-constrained tier 1 ISPs, this policy is gigantic.
Thank you for being so quick. Answer on the mailing list, please. Thank you very much.
Thank you.
We have less than 10 minutes, so we will obviously this last presentation needs to be quick, and we will have to schedule an interim given the number of presentations we did not get to.
Hello everyone, I'm Ying from ZGC Lab. I'm going to introduce our new draft decentralized RPKI repository architecture. In IETF 121 and 122, we analyzed the problems of the current RPKI repository, and then I will present a new RPKI repository architecture. We found that the coupling between RPKI-CAs and PPs will introduce significant reliability and scalability issues. For reliability issues, each RPKI object is hosted at a single PP running or designating by its CA. It means that if the PP goes offline, RPs cannot retrieve its stored RPKI data. Although about 10% of PP are hosted via CDN, but CDN can only improve the individual PP's robustness. It cannot change the fact that RPKI system has a single point storage nature. The second one is poor scalability. The number of PPs and RPs are expected to increase with the further deployment of RA and RV. Therefore, the complex and the growing number of connections between PPs and RPs and the polling-based data fetching mechanism will prevent RPs from obtaining update RA quickly. So the key idea of DRR is decoupling PPs from RPKI-CAs and designing an independent repository for RPKI. And as shown in this figure, DR has two new entities, the SAS Federation and the Monitor. The SAS Federation replaces the current RPKI publication points and provides RPKI object hosting service for IR holders. Well, the monitors act as middleware between the Federation and the RPs. They are responsible for retrieving RPKI update data from the Federation and pushing it to RPs. Let's start with the SAS Federation. The SAS Federation is composed of certificate server nodes, or SAS nodes for short. But unlike the current RPKI PPs, SAS nodes are not operated or designated by the RPKI-CAs. They form an independent federation that collectively provide RPKI object hosting service. Meanwhile, the federation will have an access mechanism to help the RPKI community select trustworthy and reliable data hosting nodes. We envision a diverse set of organizations to operate the SaaS nodes, such as RIRs, state-running institutions, and large ISPs. They may have reliable service infrastructures and strong reputations. The SaaS Federation enables redundant multi-node storage of RPKI data at the architectural level, thereby enhancing RPKI overall system reliability. Specifically, once the RPCA signs RPKI object for the subordinate INR holder, the INR holder can freely choose nodes it trusts to host its RPKI objects. Therefore, each RPKI object can be backed up across multiple physically isolated and independent SaaS nodes, thereby providing more resilience against single point of failures. Meanwhile, the new RPKI object publication information and the old object revocation information will all be announced within SaaS Federation, thereby allowing the all Federation members to establish a globally consistent, globally RPKI data view. By the way, the SaaS Federation is not bound to with the blockchain technique. Well, we are also exploring the mechanism for sharing the updated information between SaaS nodes. If you have any idea, you can discuss with me. There is a middleware layer between the SaaS Federation and the RPs. We call it monitor. The monitor has two purposes. The first one is to alleviate the connection burden between the SaaS nodes and the thorns of RPs. The second one is to proactively push update RPKI data from the SaaS nodes to the RPs. Specifically, once the SaaS Federation confirms the publication and the revocation information, each SaaS node will know the updated information and will proactively push the confirmed update information to its connected monitors. And then the monitor will fetch newly added RPKI objects from the specified SaaS nodes according to the publication information. And then they will proactively forward both updated information and newly added RPKI objects to its connected RPs. So with the monitor, DRR can achieve push-based data synchronization model and allows RPs and BB routers to timely receive update RPKI data. We envision regional networks or large ISPs to operate monitors to serve their local RPs. Finally, we will summarize the DRR key properties. The first one is high compatibility. DRR doesn't modify the current hierarchical RPKI certificate issuance architecture. It is also compatible with the current RPKI repository and allows the RA deployers to freely choose between two repositories. A second one is high reliability. DRR achieves truly distributed data storage and enables a single RPKI object to be backed up across multiple nodes. So the integrity of the RPKI data accessed by RPs will not be affected even if a node experiences failure. Thirdly, DRR has high scalability. DRR simplifies the connections between RPKI nodes and RPs through monitors. It also enables proactive pushing of RPKI data from RPKI repository to RPs. We are developing a stable DRR prototype. If you are interested in DRR, welcome you to join us. Thank you.
So we have less than 1 minute, so I just locked the queue. Thank you. We'll be continuing the discussion of this on the mail list. I know that there are people who like it and people who don't. We'll see where that goes. At this point, we're out of time, so I appreciate all of your attention, and I appreciate that everyone was respectful during their comments. Thank you.
Let's be sure during this week or next week about
Yeah, I think so. All of your right. So people just won't come. So I think that's what I would suggest. And maybe
But yeah.
Yeah,
but you mean something that doesn't, yeah, I don't think stuff. Yeah. And that statement wasn't comment about multiple solutions. Yeah, I don't expect you to do anything because you're just comparing it to the two existing. And I think that when we get to solutions, there could be more than one solution. That's what I'm saying. You don't have to, I mean, you could say, yeah, there could be more than something. So I don't know if you can say that.
we try to select dates this week and share it with you, and then we
Okay.
Sure.
Yeah. And we